Hello dear students. So let us discuss about the effect of substituents on the acidic strength of carboxylic acids. So the acidic strength of the carboxylic acids is based on the nature of the substituent present. So there are two factors which affects the acidic strength of the carboxylic acids. So the first factor is the presence of electron withdrawing groups. Electron withdrawing groups. So this is the first factors which affect the acidic strength of the carboxylic acids. So the electron withdrawing groups, like for example NO2 or CHO or COOH or an halide or a cyanide group. Okay, so when electron withdrawing groups are present in the carboxylic acid, so these electron withdrawing groups will decrease the electron density on the carboxylate ion. Carboxylate ion by withdrawing the electrons. Okay, so as a result, what happens? So the negative charge on the carboxylate ion stabilizes, and hence the acidic strength increases. So the acidic strength increases. So that means the presence of electron withdrawing groups increases the acidic strength of the carboxylic acids, because the electron withdrawing groups which are present in the carboxylic acid decreases the electron density on the carboxylate ion. So as a result, what happens? So the negative charge on the carboxylate carbon, okay, so that stabilizes, and hence the acidic strength increases. So the acidic strength depends on the some of the factors, like for example, so as the number of electron withdrawing groups increases, okay, as the number of electron withdrawing groups increases, so acidic strength also increases. Acidic strength of the carboxylic acids also increases. So next factor is that as the electronegative character of the electron withdrawing group increases, acidic strength of the carboxylic acids also increases. For example, so the fluorine or chlorine, bromine or iodine. Okay, so as the electronegative character increases, okay, of the electron withdrawing groups, so the acidic strength also increases. So the next factor is that as the distance between the carboxylate ion and the electron withdrawing group increases, so the acidic strength increases. Okay, so as the distance between the electron withdrawing group and the carboxylic acid increases, okay, so the acidic strength decreases. Acidic strength will going to decrease. Okay, so this is the first factor. So the electron withdrawing groups. So next, let us see the reason for the factors which affect the acidic strength of the carboxylic acids. So that is the second factor is the electron releasing groups. So electron releasing groups. So the electron releasing groups like NH2, NHR are alkyl groups. Okay, so alkyl groups present in the carboxylic acid increases the electron density on the carboxylate ion. So the electron releasing groups increases the electron density on the carboxylate ion. Carboxylate ion by donating the electrons. So as a result what happens? So the negative charge on the carboxylate carbon destabilizes. Hence acidic strength decreases. Okay, so that means the presence of electron withdrawing groups decreases the acidic strength of the carboxylic acids. So the acidic strength in case of electron releasing groups, so that depends upon the some of the factors, like as the number of electron releasing groups increases, as the number of electron releasing groups increases, the acidic strength decreases. Acidic strength increases because as the number of electron withdrawing groups increases, so the electron releasing groups increases. So the electron releasing groups will donate electrons to the carboxylic acid. As a result, what happens? The negative charge on the carboxylate carbon gets destabilizes and the acidic strength decreases. So the next factor is that as the size of the alkyl group, so as the size of the alkyl group in the carboxylic acid increases, so the acidic strength decreases. Okay, so acidic strength get decreases. Okay, so these are the two factors which affect the acidic strength of the carboxylic acids. So let us compare the acidic strength of the some of the acids. Okay, so first let us consider the formic acid and acetic acid. So this is formic acid and this is acetic acid. So let us compare the acidic strength of these two acids. So in case of acetic acid, the methyl group is present. Methyl group is present, which is an electron releasing group. So which is directly attached to the carboxyl group. So the presence of electron releasing groups increases the electron density on the carboxylate ion by donating the electrons. Okay, so as a result what happens? So the negative charge on this, the carboxylate ion gets destabilizes and the acidic strength of the acetic acid decreases. Okay, so in formic acid there is no such electron releasing groups are present. So therefore the acidic strength of the carboxylic acid, so or we can call it as the acetic acid is a weaker acid when compared to the formic acid. Okay, so next let us consider the example of acetic acid, monochloroacetic acid, dichloroacetic acid and trichloroacetic acid. Okay, so in case of this monochloroacetic acid, so one chlorine atom is present. Okay, so in case of this dichloro, two chlorine atoms are present. So in case of trichloro, there are three chlorine atoms are present. Okay, monochloroacetic acid, dichloroacetic acid, and trichloroacetic acid, and this is acetic acid. Okay, so since the number of electron withdrawing groups increases, so here one electron withdrawing group, two electron withdrawing group, and three electron withdrawing groups. So the acidic strength of the carboxylic acids increases. So increases from acetic acid. So in case of monoacetic acid, dichloroacetic acid, and trichloroacetic acid, so the number of chloro groups, which is electron withdrawing groups, increases 1, 2, and 3 respectively. Okay, 1, 2, 3, and 3 respectively. So they decrease the electron density on the carbon atom of the carboxylate group. Okay, so as a result, so the negative charge on the carboxylate ion, okay, gets stabilizes. So hence the acidic strength increases from mono to di to trichloroacetic acid. So whereas in case of acetic acid, so there is no such electron withdrawing groups are present. So therefore, when compared to monochloro, dichloro, and trichloroacetic acid, so acetic acid is a weak acid. Okay. So next we shall compare few more examples. So that is benzoic acid and para-nitrobenzoic acid. Benzoic acid and para-nitrobenzoic acid. Benzoic acid and para-nitrobenzoic acid. So benzoic acid and para-nitrobenzoic acid. So these two examples, let us compare the acidic strength of these two compounds. So in case of this para-nitrobenzoic acid, so this nitro group, so which is an electron withdrawing group, okay, it decreases the electron density on the benzoate ion. Okay, so that is benzoate ion, COO minus. So this is benzoate ion. So the nitro group is an electron withdrawing group. So this nitro group, okay, decreases the electron density in the benzoate ion by withdrawing the electrons. So as a result, what happens? So the negative charge on the benzoate ion stabilizes and acid makes more acidic. So whereas in case of the benzoic acid, so there is no electron withdrawing group is present. Okay, so therefore benzoic acid, okay, so the para-nitrobenzoic acid is stronger acid than the benzoic acid. So next, one more example, let us consider benzoic acid and para-amino benzoic acid. Para-amino benzoic acid. So benzoic acid and para-amino benzoic acid. So these two compounds. So in case of para-amino benzoic acid, so this amine group is an electron releasing group. Okay, so it increases the electron density on the benzoate ion by donating the electrons. Okay, as a result, the negative charge on the benzoate ion destabilizes and makes this less acidic. So whereas in case of the benzoic acid there is no such group is present, so therefore the benzoic acid is stronger than the para amino acid.